Back to Kim 1802. So I get the pleasure of talking to you about equilibrium and leChat's principle, which is a very cool and interesting lab if you give it the credit it deserves. Okay, so what I want to do first is walk you through all the supplies that you need. Okay? And you really don't need a whole lot of chemicals for this. Okay? You do need copper 2 chloride, which is this blue colored solution. And it came in a bag with silver nitrate, so you should find the two solutions together. Okay. Silver nitrate is in a brown bottle. It also has an eyedropper that you will use to help pipette out the solution. Okay. Check your thermometer carefully. Okay. And I had to go with a different thermometer than what was actually provided because I saw a split in our thermometer. So I had to get a different one that I have accessible. Okay. You need a plastic spoon. Okay. You need 2 cups, 2 of your plastic cups. You will need ice for this, and so I've gone ahead and filled a plastic cup with ice. Okay. You will need a your dropper pipette, 5 test tubes, and your test tube rack. You will need a 10 milliliter graduated cylinder, your grease pencil, your balance, weigh boats. You will need to make a concentrated solution of sodium chloride. Okay. Don't do that. Okay. So I've got my table salt. Okay. And I've gone ahead and made my salt solution. And by doing that, you add 4.5 grams of sodium chloride and weigh that out on your balance and add 15 milliliters of water to that, and then add that to your Erlenmeyer flask. If your crystals don't dissolve, you will want to heat that solution up just slightly. Okay. I have some water. And then I also have a waste container or wash water if need be. So again, you don't need a whole lot of chemicals. You're going to be doing a lot of repetitive experiments with this copper 2 chloride and silver nitrate. Okay, so first step in activity 1 is to mark your test tubes. So mark your 5 test tubes with test tube 1, 2, 3, and 4, and 5. So once you've numbered all 5 of these, so that way you can keep track of them. And I'm going to go ahead and mark 1 and 2. All right, so first step is to take your copper 2 chloride and measure 2 milliliters into 5 test tubes. So I'm going to need a total of 10 milliliters of this solution, 2 milliliters into each test tube. So 2 milliliters in test tube 1, 2 milliliters in test tube 2, and so forth. Okay. So I'm going to go ahead and measure out my 2 milliliters here. I'm adding this to test tube 1. And then I'm going to do this again and add it to test tube 2. All right, so I want to stop with those 2 for right now. Okay. Then, test tube 1 is your control. So you're going to want to make sure that you have your sheets back here available. And you're going to want to note the color of the solution. So this is your reference. So this is what you're going to be comparing test tube 2 through 4 or 2 through 5 to. Okay. So we're looking for, did changes occur? Did some temperature changes occur? Color changes? What happened when we do these next set of experiments? Okay. So as you go through, you're going to want to make sure that you're filling this table out. Okay. So for test tube 1, the control, the color of the solution would be a light blue color. I also, if you looked very carefully, I noticed that there seemed to be a little bit of some precipitate in the bottom or floating around in that test tube. All right, so again, that one's your control. So on test tube number 2, to this solution here, we are going to measure 1 milliliter of that concentrated salt solution. I'm going to wash the graduated cylinder out and put that into my waste disposal container, just to remove any of that copper tube chloride that was already present. So make sure you give this a thorough rinsing. Now 1 milliliter of the salt solution is not much, and if you happen to spill this, it's very easy to start over and make your salt solution again. But I actually do find this to be a little easier if I use a pipette since I'm not needing a whole lot. Okay. So I've got 1 milliliter into this graduated cylinder, and I'm going to add that to test tube number 2. And I'm going to swirl it around, and I want to know what color changes occurred. What observations did I make? Now, I don't want you to see this because I want you to actually do the observations yourself. Okay. And so you need to make sure that you gently swirl that solution. And you'll repeat the process again with test tube 3 and 4, but varying the amounts of the sodium chloride. You'll do the same thing for test tube 5. Okay. Now, make sure that you pay attention to the instructions, because on step 8, it says you will need both of these test tubes later for temperature comparisons later on in the lab. So be careful of what you dispose of for waste in this experiment. So according to what you have listed in the instructions, step number 8 in that yellow box says do not get rid of test tube number 4 and 5. So be very careful of throwing your waste away. Okay. Now, compare the colors of the solutions. Did the solution get a brighter blue? Did it get a lighter blue? How did the intensity of that blue color change? Or did the color change completely and you go from a blue to a pink? So make sure that you are, when you record the control, be specific, because you may become a darker blue, you may become a lighter blue. So once you complete activity 1, and that's just looking at adding different volumes of salt solution, you are then ready to go on to activity 2. Okay. But again, as you're doing activity 1, make sure that you are completing that table. Okay. You will also need a cell phone or a camera in order to take pictures. And so, again, activity 1, just measuring the different colors of intensity. And so now on activity 2, we're going to, I'm going to have to make up this one here. And let me clean this out real quick. I will need, in order to do activity 2, I do need to make the test tube for test tube number 3. Get rid of any excess salt that I had from the previous experiment. Okay, so in activity 2, I'm going to go ahead and I'm going to make up 2 milliliters of the copper 2 chloride solution. Right. So there's my 2 milliliters of the copper 2 chloride solution. Okay. Now, looking at activity 1, for test tube number 3, I needed 2 milliliters of the concentrated salt solution. Okay. Okay, so for this one, I'm actually going to have to show you the color for. So this should be what you see for test tube number 3. So this is what activity 2, your color should look like to start off with. So I'm going to put that aside for just a minute while I get silver nitrate ready. And again, remember with the silver nitrate, you have its own eyedropper, and that should be packaged alongside the silver nitrate. All right, so according to activity number 2, I'm going to take 1 milliliter of this silver nitrate solution. And when you're done with the silver nitrate, as with any of your chemicals, when they're not in use, make sure that you put the lid back on the bottle. And then I'm going to take my silver nitrate solution, my test tube number 3 from activity 1, and I'm going to add that to that test tube. Now, you should notice a very significant change in appearance for activity 2. So on your notes here, this first box here, what was the solution from the color of the solution from activity 1? Then you take that test tube and you add silver nitrate, and we add that color or appearance description or observation in this box here. So this box here, this row here, that's from activity 1. Okay. This box here is where you're going to fill out your observations in activity number 2. All right, then we are going to take test tube number 4, And you're going to add, all of this should have been done in activity 1, so you shouldn't have to be making up the solutions as I have done, that I'm doing now. This part should already be done for you. So again, if you read carefully your instructions, you are not to get rid of those activity 1 solutions, because as you can see, I'm going back to them and using them again. Okay, so for activity 3, I need to take test tube number 4. So I need to have 2 milliliters of solution. Here's test tube number 4. And for test tube number 4, there should have been 4 milliliters of the salts, sodium saturated salt solution. And take your time, make sure you know what you're doing, because you're doing a lot of repetitive stuff here, so don't get yourself confused. Good thing to do when you're done with this is to make sure that once you're done with it, go ahead and clean it. Don't set it aside and come back to, there's confusion that's going to happen. So I'm going to add 4 milliliters of salt to this. I'm going to go ahead and clean the pipette out just to make sure that it's ready to go. Okay. All right. Okay. All right, so I've got test tube number 4 here. And on activity number 3, I need to add 3 milliliters of water. Let me go ahead and clean this out real quick just to make sure I've got rid of all the contaminants. Okay. Now, add 3 milliliters of water. And we're going to add this to your test tube. Okay. Now, your test tube shouldn't have the same problem as mine. You should have some test tubes that are a little bit bigger, but this test tube that I have barely holds all 9 milliliters or 10 milliliters of the solution. Now with this one, you're going to want to make sure that you mix it thoroughly so that you have a uniform color and that you see what should happen. I'm going to go ahead and set this one aside. But all what we're trying to do here is have you predict which way reactions occur, and that's the basis of leChat's principle, is these reactions go one way, or are there some that are reversible? And if they are reversible, are there conditions or things that we can do to make them favor more products or favor more reactants? All right, so on test tube number 4, again, you should have this row completely filled out from activity 1. So activity number 3, you would now fill in this box right there. All right, and then the last activity is how does temperature affect the color change? So you would take your test tube number 5 that contains your 2 milliliters of solution, and to test tube number 5, you should have added 4 milliliters of that table salt solution. Give it a good rinse. The last one I added was water. So I need to have 4 milliliters of salt to this solution, and just in case. Now, activity 5, I'm going to pretty much let you guys do and see if you can determine what happens. So to start you off with, I'm going to have 4 milliliters of water, or 4 milliliters of the table salt solution. Again, make sure that these are thoroughly mixed. Yeah, so this is what your test tube number 5 color should appear. And you're going to add hot water to this, and you're going to observe the color change. Then we're going to add ice to this and see what color change happens. So now, on experiment number 5, or activity number 4, you're going to make a hot water bath. So you're going to need to use your beaker, and you're going to need to use hot water. If you need to warm it up, use a microwave, but you need to have your temperature to be about 65 degrees. Then we're going to put this test tube inside that hot water and that hot water bath, and you're just going to let it sit there and observe the color change. Then, once you have observed that color change, we're going to take the ice bath and we're going to put it inside there and observe the color change. So does heat shift the color of that test tube one direction? What does cold water do? Okay, so you're going to see, is this reaction reversible by making these reactions endothermic or exothermic? Okay. All right, and then we'll also need to fill out the color for this part on activity 4. You will need to use this table here. Okay. So what was the temperature of the hot water bath? What was the temperature of your ice water bath? And what color was the solution, and which way did the reaction shift? Did it favor shift to the left to make more products or more reactants, or did it shift to the right to make more products? Okay. So all of this is to look at whether or not reactions are reversible, showing you that not all reactions go one direction, and exploring the effects of leChat's principle by adding a stress to the reaction. I hope you enjoy this reaction, because this is a very cool reaction and very interesting to do. So good luck.